Hey, Ronnie here. Shall we make a game? Yeah, last time we got most of our nav mesh stuff working. So this is colliding, it's crossing over nav mesh lines. We have this line indicating whether there's line of sight. Well, not line of sight, but line of travel. It's a different thing. I still don't actually believe that that is correct, but I can't prove it isn't correct, so it must be correct. And our next thing is that we are moving on to actually using the navigation mesh to find paths. So to give an example here, if I had, say, oops, let me change the color, something more meaningful, and thicken it up a bit so you can see it. It's still too bright. There we go. So if we had like a bunch of triangles like this, right? And let's put some more over here like this. Right, if we were here and we're trying to get to here, we need to actually like cross these edges like this to get around to here. And the way we're going to do that is going to be quite crude. We're basically going to do a flood fill, basically. We're going to start here, and then we're going to like check all the neighbors, and just keep going until we find a good route to the destination. And I'm sorry. One of the factors in that is that we need to know roughly how expensive it is to travel between 2 points on the nav mesh. So let's say that, you know, we had one like this. Well, going from this edge to this edge is actually way cheaper and easier than going from this edge to this edge. And so we actually need to kind of like, I don't really want to be doing those distance calculations. We can't get away like the, you know, the square of the distance trick if we're summing them together. So I ideally want to actually pre-calculate all these distances between all these edges. And at that point, I want to, what do I want to do? I actually want to, yeah, can't store them in a list. And also we should probably store one from, say, like the middle to an edge or something, just so we can get an idea of how, just get a rough estimate of how long it's going to take to, on average, get out of a triangle if we're spawning in it or ending in it. Yeah. I keep saying triangle, but not triangles anymore. We're working with n-gons now. So this is going to be, first of all, we need to go to our navigation mesh. We're going to add a new thing in here for, here it is. Okay, for each face, for each edge within, for each edge of the face, not the gas, the face, an approximation, so the average distance between those two edges. Edge distances for each face, for each edge within, the average distance between, let's go, the distance between the distance between that edge and the, how am I going to calculate the center of the face? Because I could take the average of the points as the face, as the center of the face. Is that necessarily correct? I mean, I guess it's not wrong. And the average of the faces, vertices, and distance to edges, midpoints, edge, midpoint, distances, the midpoint of edge and the average of the face vertices. Okay. Edge, midpoint, Center distances. That will do. That's a bit wordy, but that'll do. Okay, so next up, let's just think about this. So we've got a pointer, so that's the faces. We have a pointer, so that's the hang on. Yeah, that's fine. Okay, right. Okay, all right. So next up, we need to open up our OBJ to C thing. But the other thing is I need to actually, because I need to be able to check that the data coming out of this is like vaguely correct. And it's going to be kind of hard to do that as these numbers are going to be very kind of abstract. So what I'm actually going to do is I'm going to intentionally set up some data that we can use to kind of test this. So we're going to end up with 2 points really close together, and we're going to kind of like spiral out a bit like this, just so it gets kind of like progressively further away. So this should give us kind of like a general kind of run. You know, it gets kind of like further and further and further as we go, kind of like that. Yeah, that should do. And I'm just going to flatten this out using the normal. So now it's probably kind of planar. And export that back out. Okay, so next step we go to our OBJ to C, which is this is generating code from the OBJ file. I'm going to comment that one out for the moment, and I'm going to focus on the edge midpoint distances just to get that in and correct first. So what have we got here? What have we got? I think I store somewhere the locations of the faces. Doesn't look like it there. I'm trying to remember how I structured this because it's I've slept since I last looked at this. Okay, we're getting vertex locations. That's fine. So what we actually need to do in terms of like sizing this. Yeah, let's allocate some memory for this, just so we don't have to like it. I'm being so indecisive here. I don't know what to do. Okay, remappings, surface normals. Let's iterate over the faces again. Let's just do it. Yeah, what the heck? And the footer of its edge exit intersection. It's such a terrible name. And the header of its, okay, what's this terrible name then? Edge midpoint distances. And this is just going to be a massive array, I think, of just floats. Yep, that's fine. We're going to basically add kind of like intermediate mapping tables, so we don't have to count to pull the face up to that point to get to a particular face's list of edge distances. Midpoint distances. Okay, navigation meshes, edge midpoint distances. That's such a terrible name. Why did I call it that? Anyway. So we're going to iterate over the faces one by one. And I need to check up above how I actually get the locations out, because that's kind of important. What was it? Where was it? Where was it? I'm just going to start collapsing all this up because they're not relevant. And they're making it hard to find the bit that actually is relevant. Yeah, that's right. I had this number basically counting the number of indices we kind of rolled over, so I could skip to the important part of the list. Okay, so we're using that in here. There it is. There it is. Yeah, that's right. So we're getting the number of vertices in the face. We're getting the. Hang on. We need the next one, not the previous one. Okay, right. Yeah, so we've got the number of vertices in the face, and then from that we can calculate our locations. And we're doing like a kind of like a lookup table here. So kind of like for this, there would be actually 16 entries because there's from there to there, there to there, there to there. You know, every combination of edges. And so we've got a first edge, and we get a second edge. And then we need to get the locations of either side. So I think I do that sort of, where is it? Where is it? I lost it. Ah, here it is. Okay, so look at this. So it's, yeah, that's right. That's right. Okay. First edge, second vertex. Location. Didn't I say before I was going to start writing shorter variable names, and I've just lied to everyone, including myself. And then we're going to do a second edge of vertices. Okay, and now we want to calculate the midpoint, so that's pretty oops. Don't know how I did that. First edge midpoint is going to be 3 axes, and do I have like a subtract? No, I don't. Do I have an average? No. Oh, I kind of de-refactored, didn't I? Ooh, you know what I'm going to need here pretty often, actually, because I'm also going to need to calculate the center point of the face. I'm going to have to be able to go, right, here's a list of coordinates. Average them. Actually, no. I'm not so sure. Whatever. I'll handwrite it out. It's not actually going to be that much code to write out, so I'll just handwrite this out, and if it turns out to be a mistake, I can correct it later. That hasn't bit me in the ass multiple times, has it? Yes, as we're calculating the midpoint of the line by calculating the mean average of the point either end of it. And then I'm going to do the same for the second edge. These are all still saying first. So let's sort this out while we're here. I would use find replace, but it has actually bitten me multiple times today, and I've actually just spotted the way that would have bitten me. That would have been hard to spot if I had been handwriting this. There we go. So now we need to calculate the distance between those 2 points. Okay, all right. Okay, we're good. So yeah, now I need to calculate the distance. So it's going to be, hang on a second. So it's a square root of, oh, I need to calculate the difference, don't I? Yes, I do. It's going to be second take the first. On all 3 axes, nice and simple. Good old bit of Pythagoras theorem. Who said we weren't going to use it, huh? And then we just need to write that out to the Here, we need to write that out to the file. So if the face index or the first edge index or the second edge index, then we draw a comma. Okay, that should, let's get around to the right terminal, press make. That should, oh, did I make any new allocations? I don't think I did I in the end? So let's just have a double check. No, no new allocations, that's good. So, let's go find out, oops, movie theater C. Movie theater C file, and there should be a new array in here, which is going to be the distances. Or maybe it's still building. Maybe we'll see that in a bit. Come on, build faster. What do they call it? I definitely call it edge midpoint distances, and I definitely just done a build. Where is it? Oh, there we go. Yeah, just the error got completely drowned in the list of things happening. There we go, there we go. So, how many edges do we have on this? So, first of all, let's check the count. So, 0, 1, 2, 3, 4. So there should be 16 numbers in here. And each one of them should basically be the distance between that edge and... So we've got more than 4 for a start, so that's a bit of a concern. Sorry, more than 16. We seem to have picked up an additional 9, which doesn't make a lot of sense, does it? Hang on. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it should be 25. So yeah, it is actually correct. I'm just an idiot. Okay, we should see this pattern of like zeros running diagonally from the top left to the bottom right, because each edge should have a distance of 0 to itself, right? And we can see the general pattern we're expecting is holding. So like the first edge, you know, it gets further and further away as it kind of goes along. So yeah, that kind of looks right. I'm almost disappointed. Next up, we're going to, yeah, we're missing that field. We haven't actually put it in yet. Next up, we're going to add some remappings. So this is basically going to, why do I reset that? Do I even use that in there? Oh, I do, okay. We are going to basically then output like a table that kind of like remaps that, makes it so you can easily get to a particular face's, edge lengths. So, oh, I also need to write a kind of like a header and a footer. Here, the footer of what they call again? Midpoint distances. Edge midpoint distances, and the header of it's edge midpoint distance remapping. So there we go. Edge midpoint distance remappings. Man, what a mouthful. So we actually want to multiply these together, so that, because it's a kind of like a sort of like a, what do you call that? It's a 2D table anyway. And then we can, oh, I need to rename that actually. Edge, what are they called? Edge midpoint distance. Okay, let's build that and see how it looks. I'm just going to do, can I like discard changes or? I don't get to discard my changes. I want to undo my changes. Fine, I won't. Ah, it failed to build anyway. So what do we have? Is that going to be right? Let's find out. It's entirely possible I got the type wrong in here. Okay, incompatible pointer types initializing. So it's saying, I always find it a lot easier if I grab these and I basically just put them right next to each other in here like this. So one of them has a pointer on the end and one doesn't. So we gave it something that's a pointer and it wasn't expecting one. Remove that. I don't think I will. Let's have another look at this. So this is a list of numbers and we have a list of pointers to numbers. So we're taking the address of the first one. So that should be fine. Which line is it actually raising the error on? Is it? Oh, it's actually that line. Okay. Oh, wait. The word remappings is in there. That's why. I've done this so many times. Every time I make this mistake. There we go. Yeah, this kind of like remapping list was pointing to itself rather than something else. I'm surprised C can even compile that. I wonder what it actually does. Right, so let's have a look at the data. Looks about right. Let's add a second polygon and export. It should. Yep, place the next one at 25 because 5 edges, 5 times 5 is 25. Nice. So next up we need to calculate these. So these are the center distances. And as we're kind of outputting on the fly, we can't really do it in the middle of this loop. No problem, no problem. So, so I guess we just copy this entire block here and then modify it. And we'll also keep scrolling, keep scrolling. So what do they call these? Edge midpoint center distances. Edge midpoint center distance remappings. My names again, as much as I'm saying, oh, I'll do better, I'll make my name shorter, they're not getting shorter. Okay. Edge midpoint center distance remappings. Edge midpoint center. Center. Okay, that's looking good. Edge midpoint center distances. I'm running a loop once here. We don't need this like second layer of looping, so we can get rid of. We can kind of get rid of that. Oh, actually, we're actually going to loop through this twice. We're going to loop through once, so we can look at all the vertices and kind of like average them together, and then we're going to loop through again, and then that's when we're going to do our edge comparisons. So. So yeah, midpoint is going to be here. 3 axes. I'm going to initialize it to 0, 0, 0. And then divide that by the number of vertices. So we get our mean average. And then That easy, that easy. Okay. And then, again, just add these all up so we're getting the mean average of all the points on the triangle. I need to do this silly and use the z-axis twice rather than xyz once each. Okay. So it's no longer the first edge, it's just the edge. So we can cut those out. Please don't sue me, whoever that guy was who sued everyone who used the word edge. And now we should be able to take the word first and cut it out everywhere. Oops. Cut out most uses of it. And then this can become our, it's going to be the face midpoint. I'm going to rename that, it's a bit unclear. And yeah, face midpoint. Why are you doing all that? So you rush your code, you're making me nervous. Okay. So now I just guess to see if it builds. Go. Go crazy, do what you like. Why is that rebuilding? Oh, it's got to change the header file every time I forget. Come on, you can do it anytime today. Oh, it generated code. It didn't work, but it generated code. What do we have? So that looks about right. And then our distances are here. Now, I didn't rename this, that's the issue. So let's have a look at our polygons here. So if we actually grab all the vertices of this and then we separate them out and we scale it down to 0 at the midpoints, it should give us an idea of exactly how far away all these should be. So should be able to use the edge midpoint snap up here. And I think there's an option here to see like edge lengths. There it is. So that's 0.5 meters. So let's have a look here. That didn't look right. Let's just draw them all out and then see if we can match them up. See if we can figure out what's going right / wrong here. So we have 0.27, that doesn't sound right at all. Oh, it's there. And then we have 0.44, which is that one. 0.52, which is that one. 0.41, which is that one. So it looks like it works, except it didn't go in the way I was expecting it to. So that means that one there must be edge 0, which does that still line up with my midpoint distances? Let's find out. So 3.8, 3.9, 5.7, 6.5. Yeah, those distances look right. Let's just check the next one over just to make sure. Get rid of all these. Oh, I need that actually. And then, yeah, like that. Oops. Blender has too many keyboard shortcuts, but also not enough. Also, I'm too clumsy. Okay. So, our next one should be like 394, 207. So that's right. Okay, our calculations are actually correct. That's honestly kind of shocking. The only thing we've got to fix is this up here. So that did actually work. That's cool. I was not expecting that to actually work. So next up, we're just going to put this back the way we found it. Or we would if there were enough undo steps. Oh no. Oh no. I'm gonna have to make a whole new nav mesh now. Oh well, we can build a proper maze. Let's put the camera back where it was as well. Let's commit that because that's actually a successful change, which makes a change. Two navigation meshes, okay. And let's build ourselves a, no, hang on, I was going to the, stop popping up things in Windows. Okay. Scenario movie theater, and then we're going to put the camera back where we found it. As long as I remember where I found it. Oh, I left it over here, good. So it should be just a matter of copying these over. Dead easy. Right, camera's back where it should be. Okay, next up, we need to build a little maze. So, how are we going to do this? I'm going to build it as a plane in 2D and then figure it out from there, I think. So, get rid of you. Add a plane. Or you can have it over there, that works too, I guess. And then, oops, I've still got it in normal mode, so get rid of that. The question is, which way up is this? Because I've got backface culling turned on, and hey, I got it first time, nice. So let's get the base in just so we can see what we're kind of, at scale. And let's build a little test maze for our little cube. We can see the floor, can't we? Yeah. Let's put the popcorn in just so we can see roughly where that lies. Let's rotate the camera down a bit as well. So let's put some lines in there, lines in there, in there. Get rid of the tile with the popcorn on it, and then let's do that. That's an interesting enough shape, I think. That'll probably do for testing this. And then we're going to do a little bit of optimization because we've got a lot of kind of like stray kind of like vertices and stuff. So that's a bit more optimized. Let's merge these together. And then we're going to merge all these in the bottom left corner, I think. Ah! And we can probably make this convex. These ones at least. Yeah, I probably shouldn't have split that one there. Let's put that one back in. But all of these can go straight into the corner. So I think there's like a dissolve. There you go, yeah. So that's now made us a big n-gon. So we've got very few triangles now, but they're actually very kind of like neat surface. Actually, I'm going to dissolve these ones as well. Yeah. I think that'll do for counting as convex. I think. We'll find out if it doesn't. So let's export that again. And let's rotate our camera down slightly. So say that. Oh, it didn't like that. It did not like that. Okay, it's generated some invalid stuff here. Ah, it's not actually convex as far as this is concerned. So the problem is, the actual problem is that, let me draw this in Exploit. So we have this whole feature, like where you got like sort of two edges that you can cross to exit the nav mesh triangle. Not triangle, polygon, face, whatever. And you've got this line that kind of extends into infinity where they join. The problem is when you have two edges that are perfectly parallel like this, there is no edge. So it can't calculate that kind of like up normal off there. So yeah, it's going to have to be a bit more, should we say, correct than that. So, but it should just be a matter of basically just shifting these very slightly that way. And if we've got any more vertices around here, this one very slightly that way is all it should take. Let's see if that works. Yeah, it did work. Excellent. Just flattening it back out again. Okay, and then we should be able to see. Wait, did I do that wrong? Oh yeah, I've still got not numbers in there. How about that was into the wrong place? That's just closer to the floor than I would have expected. Let's just fix these though. What have we got here? Again, we've got another case of them not being quite convex enough. Oh, it's probably this one. Yeah. So if I ever, if I do open source essentially, I'm definitely gonna have to build some better tools for like visualizing these kind of errors. Okay, that fixed it. And this cube's kind of slammed up against the corner of this nav mesh tile. Okay. Okay. So the next step is I'm actually going to adjust this camera a bit more and see if we can get into just a better position because I can't really see what the heck's going on. Okay, let's put this back the way it was and looking down. So we're going to raise the camera up, say, a meter and then have it looking down, say, 45, 50 degrees. So it should be a good like sort of plan view of this. Or not. Okay, let's try that again. Okay, we're getting closer. Just pan it down very slightly more. And then we're going to just shuffle it across very slightly, say, that might be too much. I just want to get the whole thing kind of in shot. Okay, I'm going to raise it up very slightly more. It's kind of a half a meter. As if half a meter slightly, it really isn't. Okay, so where's our cube? There's our cube. So we now have a nav mesh. We now have the edge distances. We have the collision working. So I'm going to place this cube somewhere rational, like here, and I'm going to give it a target, like say over here, and it's going to have to navigate, say across there and through there. hopefully the plan is starting to make some sense, the way it's just, sort of planned to work. Let's go up slightly more. And I get something over some more. Camera positioning is taking an age. And then we're going to go to our script, which we're already in. We're going to change the start position of the protagonist to like, yeah, there. That's a good starting point. Now, at the moment, we don't have a lot of the nice tools we'd like to have, like say, we don't have square root in the math library, which is going to be a bit of a pain. Does WebAssembly have a built-in square root? It does. Let's have a look at the opcode, and we can probably implement this ourselves. But that's gonna be a later thing for sure. Don't get distracted. Don't get distracted. Carry on. Okay, so on our target points, so we need to pick a point on this to be at sort of target zone. So kind of over there. That's gonna be a good place for it. Yeah. Now, I'm probably not going to get this anywhere near fully working tonight, but we can at least get ourselves set up for success next time. Okay, yeah, so we can now say we don't have a line of travel, so all good. Yeah, I think we're doing good. So next thing I need to do is I go to nav mesh and oops, I typed the right thing, and I need to add a function here to get to actually do the navigation. So I'm going to make something very similar to this motion result, but it's going to be a navigation result. The reason is there's actually going to be a few special cases, which I'll demonstrate in a moment. Okay, so value is greater than or equal to 0. Specify the index of the edge that the agent should cross to continue navigating. And then we're going to have one for you're already there, one for I couldn't find the route at all, and one for actually, yeah, navigation mesh results. Nope, no route. No valid route was found between the origin and destination. It is possible to reach the destination by traveling in a straight line from the origin. So yeah, if it finds us a good simple route, that's when it'll go like, oh, yeah, you don't actually need to say, walk to an edge. You can basically just go in a straight line and get right there, which should help for more sort of natural things. So like, for example, if you had, just increase this size a bit. If you had like, say, a room like this, and you had a corridor over here, I need to be careful with the draw, and like say a zigzaggy corridor like this, and your player was here, and the enemy approaching them was there. You wouldn't expect them to take a route like that. You expect them to take a route like that, right? So it actually needs to be able to go like, right, you have line of travel. Don't even bother trying to follow the nav mesh. Just go straight there. So, navigation results, direct. There's no mentions of motion anywhere on this page. That's good. So where we've got this motion result, we're going to get a navigation result. And it's going to be very similar to this, actually. So, should it be navigation or navigate result? I think it should be navigation. Determines. Okay. What's a good word for this? It's going to be. It's going to be a heuristic. Makes a best guess at the optimal route between 2 points on the navigation mesh. Okay, navigation mesh to navigate and origin face. Index the facial navigation mesh which holds the origin point. Yep, that's good. The point which I'm going to have the origin location, so the location of the points, origin point. That'll do, that'll do. And we're going to have just destination face and location. And the navigation mesh is local space. That's important to note, otherwise I will get confused and forget which space it's in. Because I am dumb. And it really is the hardest bit of, well, it often feels that the hardest bit is figuring out what you actually want these functions to kind of like, you know, what would actually be a useful function. So origin, face, origin, location. There we go, all good. So our next step is when I come to here. Oh, that's still returned the wrong type. Oops. I don't actually need that at all. Because you shouldn't ever really be calling this with the same face ID, because you should always be calling the allows travel first, really, before you call into this. Okay, so now we need to actually implement this, which is going to be the slightly more difficult part. There we go, solved it. So up here we've got our movie theatre scenario. How am I going to implement this? How am I going to have it go towards the right edge? I guess rather than this here, because at the moment we've got this kind of previous location, this next location, I guess we did the navigation kind of here. To do navigate, to do So what I can do, as just a quick sort of hack, is linearly interpolate from the previous location to the target, and oops, what am I doing? So this should, if I just make this, yeah, make that throw. Just because we're not calling it, that'll at least make it not complain about. Oh, it's still going to complain about missing a parameter, well, unused parameters. Let's make it not complain about that. This should just pull our kind of like test cube in the direction of the target. I've changed the header file. I need to rebuild. Come on, you can do it. Build faster. Come on. There we go. Oh, okay. Let's make that much slower. So yeah, that'll do, I guess, for just kind of like a quick sort of check. Okay, so next up we need to call this navigation function. So we've got the navigation results. I'm going to navigate. We've already constrained our point to the nav mesh, that's fine. Actually, we need to, hang on a second. We need to, first of all, check whether there's a line of travel. That thing I just said that we were always going to do. So from along our navigation mesh, where is it? Where is it? It is there. Yes, we're going to check if we have line of sight, and we're going from the current face, and we're already getting the target face, we can reuse that. We've got the previous location as where we're starting from, and then we've got the target face, and we have the target location. So if it allows travel, we move just towards its general direction. Otherwise, we're going to do nothing for now. Otherwise, we need to do our navigation result. No, not a motion result, a navigation result. Ah, it's because there's navigation mesh in the... Navigate, where are you? Doesn't really help the word navigate appears in all of these, does it? And then static face. And then we've got our previous location. And then we are using the target face. I'm using the target. So that should tell us what to do next. So then we check that if the navigation result is none, then actually in both these cases from now, we're just going to copy the previous location to the next. So it should do nothing regardless of whether it finds a route or not. So next up, we need to start doing some of the spicier stuff. So we're going to define maximum faces per navigation mesh. And how many do we have? How many do we have in here? We have 6. So that should give you an idea. Like, you can start building some complex maps. It doesn't take many nav mesh triangles generally. So we'll go for 128. That should be enough. And we're going to go for static. So this is basically going to be like a table of how long it took us to get there, I guess. So static best distances. And we're not going to initialize that, we're going to initialize it at the time of using it. So where's our, here it is. So we're going to get the, I think it's just called count, the number of, yeah, it's just called count. It's the number of faces in the nav mesh. If the count is greater than maximum number we can have, then for an error, too many faces in navigation mesh. Lovely. Otherwise we carry on. So we then need to go through our entire navigation mesh and we need to initialize all of them. So if it's the origin face, then we set it to, oh, hang on, I need to think about this. For now, let's initialize them all to positive infinity, because that way we're always going to be closer. And if the face is the origin face, then we need to go look up in the navigation mesh the hang on, it's the midpoint center distances, origin face, ooh, actually, no, it's got to be 0. Yeah, we won't know the edge distance until we've crossed an edge. So this is going to be actually a recursive function. Ah, joys, right? Well, we're a couple of minutes off being done, so I'm just going to carry on while I still got a bit of time. And yeah, it should be. Ooh, I've just thought, am I actually going to need these locations? I'm not going to need these locations. If we're not doing the line of sight check in here, we're only looking at the edges. We don't really care about the line of sight. We've already considered it elsewhere. So navigate. Get rid of those locations. We don't need them. At this point, we're working entirely in graph space. Okay. So I guess we get the number of edges in the, yeah, get the number of, correct that up there. Vertex count, we get the number of edges on the current face. Yep. And then I guess we kind of just iterate over the whole, yeah, we're going to loop over the edges. And then we're going to get the edge, we're going to get the center distance, near the edge to center distance. And then we're going to recurse over the whole thing and see if we can find a good route. Try to think what this function is going to look like. It's going to be static, navigate. It's going to have to take in the navigation. It's going to need the distances between edges and which ones have neighbors. So I think that's all we're going to need out of this. So I might just pass these for as pointers. Yeah, I'll pass those for as pointers. And it's going to need that, and it's going to need the edge midpoint differences. That's all it's going to need. And it's going to return a float because it's going to return the best distance, because at that point you can just kind of return, if it found a route, it returns the distance of that route. Otherwise it returns maximum, sorry, positive infinity, or maybe not a number. Maybe not a number would be good. Yeah, not a number would probably be quite good. And oh, we also need to tell it where we're trying to go and where we currently are. So and I'm just going to reorder this so it kind of matches the thing that calls it. All right, so yeah, we are out of time. Thank you very much for watching. Hopefully we'll actually get this Do I say it? It'll curse it. To hell with it. Maybe we'll get this working tomorrow. Have a great evening.